All right, let's dive into something that's, surprisingly fascinating. The ingenious engineering that goes into a removable partial denture. We're going to break down, based on the official dental manual, just how these devices solve some really, really tricky mechanical problems. Let's get right into it.
So, picture this challenge. You're missing teeth on your left side and your right side. How in the world do you build a single device that connects everything, acts as one solid unit, and has a way to securely grip the teeth you still have so it doesn't go flying when you eat? It's really two completely different engineering problems that need two brilliant but very different solutions. So, first up, let's tackle that unification problem. How do you link the left and right sides of a denture so they move and function as a single, solid piece? Well, the answer is a core component called the major connector. The major connector is, for all intents and purposes, the chassis of the denture. Yeah, just like the frame of a car. Its number one job is to provide rigidity and tie everything together. If this part flexes even a little bit, the whole device is useless and it starts putting stress in all the wrong places.
So designing this backbone is a really delicate balancing act. It has to be incredibly strong and rigid, right? But at the same time, it can't be pressing on your sensitive gums, it can't get in the way of your tongue, and it absolutely cannot become a trap for food. It's a classic engineering trade-off. You need strength, but you also desperately need comfort.
And this is where the design gets really, really interesting. Because the anatomy of your upper jaw and your lower jaw are so completely different, you actually need entirely different types of backbones for each one. It's truly a tale of two connectors.
Okay, so for the lower jaw, you've basically got two main options. On the left here, we have the lingual bar. This is the go-to, the first choice. It's simple, it's strong, and it's pretty hygienic because it doesn't cover much. But there's a catch. It needs enough vertical space. If you don't have that room, say the floor of your mouth is a bit high, then you have to go with the problem solver on the right, the lingual plate. It's basically a bar with an added metal plate for strength, but as you can see, it covers way more of the tooth structure, which can make keeping things clean a bit trickier.
Now the upper jaw? That's a completely different ballgame. On the left, you've got the AP palatal strap. I like to think of it as a perimeter frame. It gives you incredible rigidity, but it leaves the middle of your palate totally open, which feels way more natural. But what if a patient only has a few teeth left? Well, then you might need the heavy-duty option on the right, the full palatal plate. This thing gives you maximum support by covering the whole palate, a lot like a full denture. It's a clear trade-off. Do you want that minimal feel, or do you need maximum stability?
Okay, so we've solved the unification problem. We have a single, rigid chassis connecting everything. But now for challenge number 2. How does the denture actually stay in your mouth? This is where we get to talk about retention.
I mean, really think about this for a second. That solid frame is great, but it needs a way to physically grip your natural teeth so it doesn't pop up when you're chewing something sticky, right? The solution is another brilliant little piece of engineering, the clasp.
Now, the super technical term is a direct retainer, but we can just call it a clasp. And I want you to think of it as a set of tiny, custom-made metal hands. They are perfectly designed to find and grip the natural contours of your teeth. These little grippers are what provide that crucial resistance to keep the whole thing from being pulled away.
And just like our major connectors, not all clasps are created equal. There's a huge variety, but we can simplify them down into two basic ideas. You've got your simple, rigid grips for stable situations, and then you've got your smart, stress-releasing grips for the more complicated cases.
Let's start with the simple grips. These are what you use in what the manual calls tooth-borne cases. That just means the denture is replacing teeth in a gap that has a strong, healthy tooth at both ends. The whole device is supported by teeth, so there's not a lot of rocking or movement going on. It's a stable situation.
And the absolute workhorse here is the Acker's clasp. It's this strong metal arm that comes from above the widest part of the tooth, kind of its little bulge, and it flexes just enough to snap into that natural groove below it, which dentists call the undercut. It's simple, it's super effective, and it provides fantastic bracing. But what if you're missing your back molars? Now you've got a tooth and tissue-borne case. See the problem? One end of the denture is supported by a solid tooth, but the other end is just resting on your soft gum tissue. When you chew, that soft tissue is going to compress a little, and that causes the denture to rock. If you use a simple, rigid grip here, it could literally twist and damage that all-important supporting tooth over time. This is where the engineering gets really clever. Just watch this. A stress-releasing clasp works dynamically. So when you bite down and the denture presses into your gums, the clasp is designed to move and ever so slightly disengage from the tooth. That movement releases those potentially damaging twisting forces, protecting the long-term health of that crucial tooth. It's absolutely brilliant.
The classic example of this smart grip is something called the RPI system. The name just stands for its three parts: a rest on top of the tooth for support, a proximal plate on the side, and a flexible eye-bar clasp that comes up from below. The genius is in how all three of these parts work together. As the manual describes it, when you chew, the whole assembly rotates in a way that makes that eye-bar move away from the tooth, perfectly releasing the stress.
So as you can see, you've got all these different components, different backbones, different kinds of grippers. Putting them all together isn't like picking from a catalog. It is a process of highly customized design for every single person.
And this quote from the manual just perfectly captures the whole philosophy. The goal isn't to force some standard design into a patient's mouth. The real goal is to carefully study that patient's unique anatomy and then engineer a solution that works with what's already there, without having to change things if you don't have to.
So the big takeaway here is this. Choosing the right parts is a really complex clinical decision. A dentist has to analyze everything, from the exact shape of a tooth and where the undercuts are, to the patient's aesthetic concerns, and even thinking ahead about what might happen in the future. Every single partial denture is a totally unique, custom-engineered solution for one person. And that kind of leaves us with one final thought. You know, in today's age of permanent, high-tech solutions like dental implants, what's the role and what's the future for these incredibly clever but still removable little pieces of mechanical engineering? It's definitely something to think about. Thanks for joining me on this one.